Hi. Hopefully you have had a chance to look at what we talked about in the recap. And the good news is the recap and what we did last week is very data driven. Having said that, I think the onus on you, I think I've said this about these 2 weeks, the pressure on you is to do a lot of the assessments as we go along, more so than in the previous parts. And the reason is, what I'm doing in these 2 weeks is giving you the essence of risk and return. And although I'm using data and giving the intuition, I'm not going to do the execution of how to estimate betas, how to do covariances, and so on. And I tell you, you may or may not need to do this. That's so awesome for finance. But I encourage you to do those assessments and homeworks, because what it'll do is it'll kind of make you learn statistics while you're doing finance. So it's like a 2-for-1 deal, right? So please, I hope you have a good grasp of the measurement of things. And this week again, we'll focus largely using examples. I mean, numbers as a takeoff, I use numbers, real numbers. And then we'll also go to the website and do some analysis. So there'll be numbers and real world data everywhere, but I'm not going to spend a lot of time, if any, on calculating means and variances and covariances of betas. Okay? So let's get started. This is the second week of risk and return. Diversification is the sole basis of everything. And I said so. We like return, we dislike risk, we diversify, therefore we hold portfolios. And we saw what that does is it reduces the risk that we confront as measured by standard deviation. Now please pay attention to this. Suppose I wanted to show you diversification and I have one asset over there. By that I mean a stock, a bond, a house, whatever. So suppose you hold one asset security, and suppose that security's name is Google and it's your portfolio. What do I mean by that? That there is just one investment in your portfolio and you put all your money into Google. At least I'm picking something that everybody would agree, most everybody, is an exciting choice. But therein lies the catch-22, right? You get excited. How would you measure the risk of Google? Remember, I showed you some numbers and I didn't show you Google purposely. Go for yourself, take the time before, now, or whenever, and find out the standard deviation of Google. And what you can do is simply get returns over the last 20 years like we did and estimate Google's volatility. And the risk will be measured by, and we know this, right? Sigma square Goog. By the way, that is the symbol that Goog has on the stock exchange. I believe Google is called Goog. And if I screw that up, you can always Google. Sorry, unintended pun. Okay, but you'll see that we'll use this many times too. So I'm going to interchangeably, if I talk about risk as variance versus standard deviation, don't get too thrown off by that, because one is just the square root of the other. And in the real world we do, I mean, in conceptually, why do we square? Because otherwise if we added deviations from the mean, they would all be zero, add up to zero. How would you measure the risk of your portfolio? So remember, your portfolio risk was called sigma square p, or standard deviation was sigma p. So notice what I've done. I put all my resources, money, in one investment, which is, by the way, physically impossible to do these days, and I'll say that in a second, but just imagine you've done that. What will be this? This will be equal to, depending on your measure, Goog or standard deviation of Goog. In other words, What's going on is, I want you to recognize what's going on is that the portfolio's risk is identical to your risk. Meaning, sorry, not your risk, Google's risk. Does that make sense? Why? Because you've only one investment. Okay? So let me just make sure I have a clean slate to work on and go on to the next point. What is the relationship between the two? We just saw they are equal. So we now are going to step to two assets. But before we go there, I mentioned to you it's almost impossible that you'll have your investment in one asset. And the major reason is diversification, but the other reason is whether you like it or not, you're investing in yourself. Whether you like it or not, you have investments that you don't even know. So you all about, right? You may have invested in a house. You think broadly when you think investment. Don't think just a stock. So in some senses, this artificial one asset example was created to make you think about risk and return. So if you have one asset investment, what are you confronting? You are confronting all the risk of that asset. In other words, all your eggs are in one basket. What are the two sources of risk you're confronting for each separate investment? So take a Google example. The risk of Google was a risk of your portfolio when you had only Google. What kind of risks does everything have? Two generic risks. Market, Google goes up or down, regardless of Google's own actions or specific things, because the market is going up and down. Why does the market go up and down? If I knew the answer to that, I don't know what to say. Some people think about how markets go up and down. I'll tell you a little story in a second, but when the time is ripe for it. So markets go up and down, Google goes up and down. But there's a second reason that I'm going up and down with Google, and that is Google makes mistakes. Of course it does. I mean, everybody does. Google makes good decisions and mistakes, and it'll go up and down due to things specific to Google. Had nothing to do with the marketplace. When you're holding only Google, your portfolio variance is the same as Google variance, or standard deviations are the same, and therefore you're going to bounce up and down due to both reasons of risk. Now let's go to two. Suppose you have two securities in your portfolio, and one is Google and the other is Yahoo. Just if we have time, I'll do this, but I will clearly remember to do Google and Yahoo as we go along. But look at market caps of the two, and you'll see one is a gorilla and the other is relatively small. And which is which, right? So suppose I say, okay, I'll have a big guy and a small guy in a portfolio. How would you measure the risk of each of the two stocks? Right? So what would you do? You would have you will have sigma square Goog or sigma Goog and sigma square Yahoo and sigma Yahoo. Those are two alternative ways. They are the same. One is the square root of the other. So do you understand what I'm saying? Is that we saw it in our data that you could measure the risk, and you can measure the risk of each one separately, and that's called standard deviation or variance. Okay? Now let us look at what happens next. How would you measure the average risk of the two? We know how to do it. So assume you have put the same amount of money in both. This is going to be important down the road, so I just wanted to highlight it. As soon as you put all your money in one thing, you don't have to worry about weights or what proportion you put. It's 100%. But as soon as you put in two things, you have to worry about the standard deviations of the two, and the average risk of the two will be the average standard deviation of average variance, whatever you like. But with one caveat, you have to worry about how much money went into Google and Yahoo. So you'll just do a simple average if you put 50-50 in each. Okay? Very simple. So let me just write it out here. You'll just average half sigma goog plus sigma Yahoo. I'm just mimicking what we just saw in the data earlier on, right? Fair enough? Let's now ask you the following. How would you measure the risk of your portfolio? And if you are understand, I mean, I'm throwing out questions, I'm going to, next questions are deeper, right? So I can't just do it. So that's where we are headed. How would you measure the risk of your portfolio? The intuitive answer is actually not right. The intuitive answer would be what? Let's just think about this for a second. The intuitive answer would be sigma p should be equal to this. Sigma p should be equal to this. And that's not the answer. Because if that were the case, what would we have seen in the 11 securities in the S&P 500? The average of the 11 securities was much higher than the sigma p, and the reason was diversification. So we'll come to that. That's one of the major things we have to show. Is the portfolio risk the same as the average of the two? And the answer we have just said, if it were the same, there's nothing to talk about. We just saw last week, and we revisited the whole data. The one amazing thing was that sigma p was the lowest in that particular context of all. Okay, and that notion is called diversification. Again, using data to motivate theory. Right? Okay, so let's move on and see what the heck is going on. And by the way, now comes a little bit of pain. And let me go back to last week. When I said diversification is the fundamental driver of definition of risk and definition of the relationship between risk and return. And not just definition, actual measurement of it. What did I say? Is that all of us will hold portfolios. And portfolios are what? A group of things. So imagine two people, one person in a room, Google. How many personalities? One. Think of its variance as capturing that personality. Right? Now you have two things in your portfolio, Yahoo and Google. How many personalities? Uniqueness. Two standard deviations. Yes? Two people, Mr. Google and Yahoo in a room. Their personalities are important because there are two of them. However, the two more things will crop up. What are those? When Yahoo is moving, how is Google moving? When Google is moving, how is Yahoo moving with each other? Those are called relations. So please keep that at the back of your mind, and that's where we are headed. And we know how to measure relationships. How? Covariances, but covariances have the tragedy of being unit dependent, so correlations are more intuitive. So let's move on. Some definitions. So some definitions I have already done is that we are going to talk about sigma p. We are going to talk about covariance, or which is also called sigma. If it's A and B, we'll call it sigma AB. And if it's correlation, we'll call it correlation AB. This is called correlation. And how do we measure it? Sigma AB divided by sigma A, sigma B. Not comma, sorry, multiplication. And what happens as a result? We get it unit free. And this number is between -1, 0, 1. Rho A, B. Okay, so these are the definitions. One last definition which is very important to everything we'll do is we will say X A is the amount of investment in A as a fraction of your total investments. Okay? Is this clear? And we are going to focus largely on risk. But remember, when you're holding a portfolio, not only are you measuring risk, what will you also measure? Return. And something is very straightforward about that, and I want to just write out another set of notes for you. One more set of definitions and you'll be all set. So till now, everything more or less was about return. So let me ask you about risk. Let me ask you about return on a portfolio. And this is so simple. So return on a portfolio would be, say, two assets, XA, return on A, plus XB, return on B. What is XA? Proportion in Google. XB, proportion in Yahoo in our particular example. What are these? Return on Google, return on Yahoo. Now the nice thing is, if I have the last 50 months or 60 months of return on Google and 50 or 60 months return on Yahoo, what can I do? I can measure the average return on Google, right? We did it, mean return. We can also measure the average return on Yahoo, yeah? So suppose this is 15% and suppose this is 12%. The average return over the last 60 months. The good news is, suppose this is half and suppose this is half. Guess what the average return on your portfolio is? It is so easy. It's linear. It's half of 15, which is 7.5. Half of 6 is, half of 12 is 6%. So this is 13.5%. So the average portfolio return is just linear. So suppose I have 500. Well, how will you figure out the portfolio's average return over the last 60 months as a predictor of what you think you'll get? Just the average of all the averages in the portfolio. So the good news about returns is because there are no squares going on, it's linear, right? So that's another way to think about why risk becomes bizarre. It's because it's squared, right? Anyway, so that's a kind of a silly way of thinking about it, but useful nevertheless. Okay, so we are done with symbols. Let's get on to what is the famous formula. And I apologize, there are a lot of symbols, but let's try to think about this. So what's going on? Sigma square P is what? The variance of your portfolio, right? What is XA square? The proportion of wealth in Google. What is sigma A square? The variance of Google. What is XB square? The weight or proportion of wealth in Yahoo in our example. And sigma B square is the variance of Yahoo, right? So we are okay till here. Remember, we are okay. We know this, we know this, we know this, we know this intuitively. Now things start happening which are a little bit strange. And that is, this shows up. This is the what? Relationship or the covariance between Google and Yahoo. Why XA, XB? Because they are like married to what's going on. So let me write out what the portfolio return is again so that you are. This is what RP is. It's a combined return of the two, where XA, XB could be half and half, or they could be 2/3, 1/3, depending on your investments, and RA, RB are the unknown returns. They change over time, right? Everybody okay? So why am I squaring XA square? Why is this squared? Why is this squared? Because variance squares. Because if you don't square, what happens? You add up all the deviations from the average, you get 0, right? So the key here is, this is there, this is there. What would sigma A square be? Let's pause a second. When would sigma A square be equal to sigma square P? When all your wealth is in A. Let's assume that's Google. But you will never do that. Why? Because you're risk averse. So let's assume you pick up Yahoo. So what is sigma B square Yahoo? The risk of Yahoo if you were holding Yahoo by itself. So those two unique characteristics, those variances, have to be there because you have two securities now. But now look at what else you've added. You've added a relationship between the two. Why is it 2 times? Simply because, unlike human beings, where my relationship with Ryan and Ryan's relationship with me are not identical, in data they are for Google and Yahoo. So sigma AB is equal to sigma BA when we measure it. So that's why the 2 comes, right? Whereas I really like Ryan, he may not like me, right? So the relationship doesn't have to be identical for human beings, and typically it's not, but in the data it is, right? That's the beauty of dealing with inanimate, non-human things like Google and Yahoo. So you have 2 times that, but the unique relationships are the same. In life, they could be, I'll separate the 2 out. How many total are 2? How many unique? In this case is 1, because A and B are the same as B and A. Everybody okay? Yeah? What's the tragedy of sigma AB, the covariance? The tragedy of covariance was it's unit dependent and its extent is not known and all that. So we defined something called rho AB as sigma AB divided by sigma A times sigma B. So what can I do? I can take this to the other side and replace sigma AB by this. That's all I've done. Everything else is identical. And please, I'll let you stare at this for a little while. And we'll take a break after this, simply because this is the one equation which is very important to understand, and then we'll only build on it. Why? Because we don't hold 2 securities. What do? We do mutual fund investments. And it makes sense, and I'll talk about that in a second. Okay, so 2XA rho A. So look at this relationship. I want you to pause. Given standard deviations are fixed of Google and Yahoo, given those 2 numbers, what's driving this relationship up and down? Do this for yourself during the break. When will sigma square RP, the risk of your portfolio, when will this be such that you will not diversify at all? Think of it. So what is the condition under which, both intuitive and mathematical condition, under which there is no benefit at all of putting Yahoo and Google together? Having said that, let's just one more time see how many terms are there in my portfolio. 2 personalities, weighted of course by the sigma A square, sigma B square. How many relationships? 2. And they are exactly the same. Okay, so we have 4 things going on in the portfolio. 2 personalities and 2 relationships. Same thing as what's happening in a group of 2 people. 2 personalities and 2 relationships. Okay, pause, think about this, and then tell me, when would you not benefit from diversification in this example? See you in a little.